but I've seen a lot of questions and discussions about sampling. I would think that sampling thing, if you know a little bit of math, is the easiest thing. There was also some discussion about the KL summarization that prompted me to change the text in the homework a little bit, right? So when we say KL between PD and PS, KL is just, you can call it distance between distributions. If you don't like this name, KL, it comes from the names of the guys who invented it. But it's really measuring how close those two distributions are. In a discrete space, distributions have a support, say over students or over images or over words or over something. If I have two distributions over the same thing, I can measure how close they are. There are many measures, by the way, of measuring the distance between distributions. This is the most popular one. It's not really a distance because it's not symmetric. Usually when we say distance, we swap those two things, get the same. In here it's not. And we really want PD to be fixed and PS to come from the summary. So I'm not keen of how exactly did you interpret this quantity. It's not like our purpose here is to go in and check your equations in the code. What I want you to think about is, okay, I want my summary to fit the document. Right? And so I compute a distribution. Typically those distributions are over words. But that is really up to you. The support, if you want to have diagrams there, or concepts, or topics, or something, that makes more complicated. But the problem is posed as this, that distributions over words. So PD is a fixed distribution that you get from the document. PS, it's a summary distribution that you build up. The more you add sentences, the more you grow the summary, and the more PS is changing. So you want to end up with a PS that's close to the PD. You're gonna, typically people do this in a greedy fashion. This would be a global optimization problem that's not easy to select the first sentence until you look at all possibilities of selecting sentences. But typically we do it greedily. We pick a sentence and then we say, what's the second sentence that will make this go down, decrease the distance. And we pick the third sentence that added to the first two will make this go down, and so on and so forth. So I want to be clear that I'm more interested in the wrapper. How do I pick a sentence that does the following thing than the actual equation? Like if you do these distributions over some words versus other words, or how exactly you compute PD and PS, that's pretty much up to you. The biggest difference, I should say, for people who are really interested in text processing, the biggest difference will come not from KL distance or greedy versus not greedy optimization sort of thing. The biggest difference here will come over how do you manage the support set. If you manage somehow to do, well, this is part of natural language processing, to shrink the support to only the things that matter, that high in content, things like names, locations, dates, things that are content-wise important, then you're likely to get a better summary. Otherwise, inevitably, in all those problems, the biggest question is, I'm trying to match those distributions, right? But the matching includes all kinds of items that are really not that important to me. Like how many times the word tweet appears in that document. Oh, 17 times. I'm trying to match that 17, my PS to be also like proportional with 17. That's okay mathematically, but the word tweet may not really be important for a word content-wise for that document. So matching that is not that good. The biggest difference in these cases would be how much ability do you have to filter out items, in this case words. But you can do this over a richer support set if you like to. How much ability you have to filter out things that are irrelevant. Just one more thing. Those abilities come from multiple ways. It's not part of our class. We do a little bit of that in information retrieval and more of that in natural language processing. Of course, there are automatic tools. Everybody knows about stop words, right? Removing stop words seems like an obvious thing to do, right? But then I can run some NLP package that does name entity recognition, another one that does part of speech recognition. And I can go now to those part of speeches and say some of them are more important than others, like adjectives are not that important because even though they have a sentiment value, good or bad, it's hard to match adjectives. Like they come, the positive ones come in so many flavors, right? Rather than nouns, which are much more easier to match. Say if this document talks a lot about, I don't know, Brazil, then I should include Brazil in my summary, right? Nouns are easier to match. But what else can I use? Everybody knows those things, right? Name entity recognition, general tool. It's not that accurate. Name entity recognition doesn't work that well. Google has this Google graph that has the best name entity recognition in the world. It's the best because it has so much data, not because their algorithms are fancy. Part of speech recognition works extremely well, 98% accuracy to give you the tags. Stop words, lemmatization, abbreviations, acronyms, so that's fine. What else can I use? What other source of information I can use to filter out the support center? I'm looking for a non-general tool. So everything I said so far is general tools that could be applied equally in news articles or in medical documents, right? Although medical documents might have some terms, especially acronyms, that are very specific to them. But what else can I do to shrink out the support set or to make it more interesting? This is a general problem, not just related to summaries. That's also general. Length of the document, references in and out, incoming links, outgoing links, whether those are web page links or references from, say, other papers to my paper or pointings. That's all. I call this general stuff. That you can approach these to if you have medical documents or news articles or trial law documents or academic papers. All these ideas would work, right?
Well, you can do things that are specific to the domain you're looking at. Like for news articles, maybe headlines are very important to determine what the article is going to be about, but not necessarily for other types of.
So yeah, this is one answer, that if I know what kind of domain I have, say news articles, probably stuff coming from the headlines, the title, or from a web link or from a menu, it's more important than general stuff of the body, right? This is general, maybe in general that you wanna, a lot of articles may have side informations, but it's very different from news versus, say, medical documents. So that's one thing. The other thing might have to do with my own purpose. Why am I creating a summary, right? Summaries, of course, this is a general formula, but summaries, there's one thing to say, I want a Wikipedia sort of summary that says, okay, this is everything that's known about diabetes. How do I summarize it so somebody, like not a doctor, looks at it and say, what's up with diabetes, right? That's actually a general population. But I can summarize things maybe for a particular purpose, as in if I write a summary for, say, I work on an economic plan or something, or a business analysis, and I know my boss is looking for, say, a strategy to cut costs or something like that. I'm just inventing this right now. It makes more sense to summarize it for that purpose that I've been asked to. How do I cut costs? There's like 1,000 pages of stuff here. I'm only interested in the items that allow me to cut the costs, right? In a medical sense, if I summarize for, say, billing purposes, that may have to do with what is the main procedure, the main diagnosis of this case, because billing go by what happened. But if I summarize for, say, a doctor or a patient, I may want to summarize in the sense of what you're supposed to do right away. The most important thing for you as a patient is to take care of the following two things. even though everything might be in that medical record. If I'm a news corporation, when I summarize an article, I may want to point out the most stringent facts about, I don't know, there was been a strike, military strike, or there has been some event happening. People, like an earthquake, say, may be better than a military strike. An earthquake, people will care immediately about where it happened, when it happened, how big the problem is. And then there's all kinds of other informations that are related to this. But, so that's a parenthesis about text in general. What else we have difficult that even the TAs have trouble with it? Did anybody manage to run this Rouge package? Did we? Perl version?
Not in Perl. I got it in
the Python.
Python, yeah.
Yeah, so the
Even
Python one
still cannot run it.
cannot run?
Yeah,
No,
yeah.
Python one, people have run it.
Python one is.
Python runs, but it's not the Codex course. That's not your fault. My purpose here is not to teach you text matching. What Rouge does matches the gold summary with your summary. And now the reason it produces the wrong score is matching is not that good as it's supposed to be. I don't want to get into that, so if you run the Python one and get some values, you'll get the full credit for the homework. But if you want to run the real Rouge, it's known thing, the Python one, it doesn't give you the Codex course. So I know one of my students managed to run it, a PhD student, but the TAs have a hard time doing it. So I'm looking for talented people who manage to run the Perl script, okay? But if you can't run the Python one, that's fine too. Okay, so today, by the way, there's an exam, right? We established that. We moved the exam 2 hours later. It's not at 10, it's at 12, because some people have that day a different exam. Will give them time to breathe. Is that okay with everybody? Time at 12? I do not intend the exam at all to be a time pressure exam. So whatever happens, I do not intend your grades to depend on the fact that you are a fast coder, fast programmer, or not. Although programming as a skill will matter. So will be 2 questions. There'll be some data and some algorithms that are involved. I have this data set, my purpose is blah, I'm trying this algorithm blah, it doesn't work because of blah, what should I do? Kind of thing, right? It won't be straightforward. It won't be run PCA on MNIST again, right? I mean, it's not gonna be that. There's gonna be something that's gonna force you either into a little bit of thinking what makes sense here, or a little bit of trying. Okay, let me try a few things, see why that is. Okay, but I don't intend this to be crushed up like, okay, only the best programmers and the fastest people will finish. That's not my intention. My intention is rather to verify whether you can do this kind of work like you did in the homeworks, but not with TA support and other people's support. So you'll be allowed to have access to the internet, to like general internet, but you won't be allowed to have anyone in particular to talk to, as in put your friend, stand by. Hey, I'm gonna call you during the exam, give you a problem, see if you can solve it for me. That's not allowed. What?
No phone a friend?
No. But if you want to Google to see, okay, how people parse this data set, or how people run PCA, or how people do this and that, that's fine. Okay? And the general approach of the homeworks, you can run libraries and so on and so forth, that's the same. So I think those problems, once you know what you want to do, can be solved in about 1 hour each. Once you have a clear plan, this is what I want to do, but you'll have about 6 hours. So you'll have 2 hours of wandering around for each problem. Okay? I didn't decide yet how to evaluate what you have. You're going to have to submit something like either a zip file or a PDF file. But then I really don't want to sit by myself in front of a computer with all those zip files. So I'm wondering if you should explain somehow a little bit what you've done, or I'm still working on how this is going to play out once I get everything you wrote down. That's not decided.
We did a quick demo after we do finish it.
Yeah, I think that's too hard for people after 6 hours to do a demo at the end. I think that would be too much trouble, and maybe for me too. And to ask people to come the next day, say, That will be people, I think, are looking to buy tickets and leave, get out of here, don't see this Virgil guy again, ever. So I'm a little bit skeptical of saying everybody has to come the next day and show me what I've done. What we're gonna do instead, I'm gonna ask you for an explanation. This time you're gonna have to write an explanation, but we won't grade how you write it during the exam. Be like bullet explanation, this, and that. So to facilitate me or the TAs looking at what you've done. And then we might ask you some questions by email. If we really don't understand what you've done, we'll be like, okay, what happened here? Can you explain this to me, why this runs? Okay, things like that. I hope for most people that. So there'll be an exam Wednesday, I think 2 weeks from today's date. Now today,
So what's the percentage of the final score?
I don't know, if you guys do very bad, we'll make it a small percentage. No. I won't be as much as the typical exams. I think typical exams are about 40%, right? I mean, a general class. In algorithms is more. In algorithms is like 70% comes from exams. In here, we'll probably like, I don't know, 20% maybe?
That is typical exam.
Hmm?
Yeah, that is typical exam, 20%.
Yeah, but in class you have 2, right?
Yeah.
In many courses. That's my, yes.
The questions won't involve training a model or something, right? Because that will take a lot of time.
That was what?
The questions won't involve training a model or something like that.
They will, but they will be appropriate for the time you have. So we won't give you a data set and a model to train that takes 6 hours. Right? We will do something appropriate for a laptop that's a reasonable laptop with a 8 gig of memory or something like this. And I don't want you guys to spend most of the exam times on waiting for the computer to train the model.
We would need power supply for 6 hours.
What?
We would need power supply for 6 hours for our computers.
I think 6 hours would be enough. I don't think the data sets will be that big to
We need to set power supply for our computers for 6 hours. We are
powers, yes.
Yeah.
There will be, I'm arranging with the administration to have some power cords or something, so everybody needs to bring a laptop and a charger that works. Okay. Okay, yes.
When will be the 6th assignment due? Last assignment?
I don't know. At this point, I'm not worried about the deadlines. My only worry is so the TAs can demo it. So if you demo it by the time you take the plane back home, or whatever that you do next, that's fine. So there's no effective deadline other than the TAs need to demo. And the 6th assignment will be easier. So I think the 6th assignment reasonably will take 1 day if you do just that. Full time, you start tomorrow morning, you should take you 1 day to do. Okay, now about the 6th assignment. So what I'm going to talk about today is something that I think you already know. So in that sense, I don't think it's very interesting, but it would be like, make sure you actually know, okay? So I'm gonna talk about graphs and social networks a little bit. But we may need to recap some parts of graphs, right? So let me see. Everybody knows about social networks, I mean, right? Do we all have Facebook accounts, Twitter accounts, WhatsApp accounts, Instagram? I don't have any of those, by the way. Not because I'm worried about privacy, not at all. In fact, many people can open my phone and my email. There's nothing to see in there. I found them too distracting. I can't get anything done if I'm involved in, say, Facebook. But that's just me. People have a lot of those, and there's a lot of work into what impact those things have in the society. Really, if you followed the news recently, apparently Facebook has a lot more impact into society, other than sharing your friends' pictures, than people thought. So there's discussions up all the way to the FBI and the Congress and all that, with how much impact those social networks really have, and whether that's a good or bad thing. So I think you know what I'm talking about. There's a discussion that through Facebook, somebody managed to influence an election in a much more powerful way than it was thought to be possible. Irrespective of the amount of money this entity had, because I could buy ads, and what's not clear is can I influence people, right? I mean, let's assume for a moment, let's discuss this case, let's assume for a moment the vote was correctly counted. I'm not including the possibility here that somebody hacked into the voting machine and changed the count. That has nothing to do with Facebook. If I can manage to hack directly into voting machine and change the count, I don't need to pay nothing for ads, and I don't need Facebook, right? I can just hack into the machine at the end, change the count, and I decide who's the winner. Let's assume that didn't happen. The votes were counted correctly. That still preserves the notion of democracy, right? As long as you could go to the booth and vote for whoever you wanted, based on whatever influence you had from either your parents or your friends or Facebook ads, as long as you voted for who you wanted, and that vote was counted correctly, you could say democracy works, right? Nobody can control what's in people's minds and how they vote. Whether you care about some emails that were sent from a basement server or you care about education, that's your problem. I mean, democracy works like that, right? So, now, if that's true, is it a problem that people could influence votes through Facebook? Isn't that what a campaign is supposed to be? What is a political campaign? A political campaign is candidates advertise themselves, and everybody tries to influence the votes, right? Before Facebook, there were meetings and ads in the newspapers and whatever. All those things were not exactly trying to influence the election. That's what they were. So now other entities are trying to influence this through social media because people pay a lot of attention to social media, right? So is this a good thing or a bad thing? Some people argue it's a very bad thing because Facebook is hard to control. We don't know who influences what, and we don't know exactly how money works. How much money buy you how much influence? Because on Facebook, that's not very clear. You put an ad. See, on a TV model or a newspaper model, it's easy to measure the money impact to such a thing. But on Facebook, that's quite hard. Number one. Number two, Facebook doesn't have the typical borders or restrictions that a broadcasting service or a newspaper service has. So as it happens, some entity from Russia perhaps or other countries could influence this just as well as an American company can. So some people say that's a good thing because you get exposed to more information. If you get only exposed to, say, American influence, you may not know some things that only other parts of the world know about. So in some sense, people say you've been exposed to more information about the candidates, you had a better opportunity to choose the one you wanted. This is a tricky thing to do. Like if you are a voter, I don't know how many of you, most of you are not American, but if you are a voter, would you like other entities from outside the United States to point out certain things about the candidates, good or bad things? Is that a good thing for your vote or not? But the real problem is how much ability do I have to influence things through, say, Facebook in a way that I want, counting on people being naive, right? If I tell you this person did this and that, sexual scandal. It's Americans' favorite, so to speak. In other countries in Europe where I'm from, sexual scandals would be a problem, but not a big of a problem. Most people would be like, okay, that's not my problem. It's their wife problem or their family problem. And here in the United States, people love sexual scandals. Maybe not, I think, the latest president managed to change all that, but before him, certainly, sexual scandals were the #1 influence. Like it was believed that no politician of any kind can pass through a sexual scandal. Like it was the absolute third rail, you touch that, you're completely done. Apparently, that's not true. Everybody's more liberal now. So if I want to say something false on Facebook, how many votes or how many people's mind can I change before that proved to be false or before the impact dies down, right? All those influences have an impact window, right? And how should I do this to maximize my impact? without letting people the ability to verify the information, it turns out the biggest influence I have in general commercial ads is things that are not quite true. But by the time they verify it, I need the impact to have its effect. So how do I do this? That's where Facebook is fundamentally different. I can have a huge impact on a very short span of time, right? If I drop the news at the proper thing. And I can influence a lot of people who would not be able to verify this independently. You know, people who are in the journalists or people who have typically a degree, like they're educated, they would pop up some question marks. Wait a minute, how this works? Why this happen? Are you sure? You know, but most people on Facebook would not ask these questions. And by the time we could verify, then the damage, so to speak, has been done. So the real problem today for this is regulation. It's not the Facebook problem. Just in case it's not clear, but I think it's very clear for you, computer scientists, Facebook's business model is to sell your data. Whatever the guy says on TV, if they don't sell your data, they don't make money, okay? As opposed to the Apple model, which is to sell physical devices. So this idea that Facebook will not sell your data, protect your data, that means they're gonna go bankrupt if they do that. So if you are on Facebook, you should not have this expectation of total privacy, independent of what Facebook says, because that means they will be bankrupt if they do that. Right? But most people don't bother by that. Like, most people are okay with getting ads based on their profiles or whatever emails they send if you are on Google site. And those ads, presumably, they read your profile and such, right? The problem is neither on the consumer side nor on the Facebook side, because Facebook will make money as much as they can in selling ads, and you might be, if you're bothered by those ads or you are worried about the how much influence Facebook has on your, say, political vote, you can shut down your Facebook account, or you can just not read the ads. I don't know. The problem is regulation from a government point of view, right? How can a government in a Western democracy go over Facebook and say you have to implement the following rules? It's not as easy as in a medical domain. It's much easier to say protect a medical record. As a regulation, it's still hard to do in practice, like how do you store it and how do you make sure nobody has access to it? That's a different thing. But in here, it's a hard thing to regulate something like Facebook. So then, what are the problems in a social network that we want to take on? Here's, I'm going to draw something. Say you have this. So we have, okay, nodes are entities. Say people. That's Facebook right now. And the edges are relations, friends. I'm using Facebook as an example, but in different social networks, there's a different kind of relation. All social networks have people or entities as the nodes, but in Twitter, what would be the edges? Followers, right? And do I have edges that are directed here or undirected?
Undirected.
Huh?
In Facebook's not
Facebook.
So they could be undirected. Typically undirected means the entities are the same kind. Like me and you, we are two people, we have a friendship on Facebook, right? But even on Facebook, some of these are actually directed, even though they're not marked that way, with entities of different kinds. How many friends Cristiano Ronaldo has? I don't know, 20 million? Do you think that's a reciprocal relationship? Like if everybody who's watching Ronaldo's pictures, if Ronaldo watches their pictures back? Because I don't think that's true. I don't think Ronaldo looks at the pictures of his 20 million friends on Facebook. I don't know the number. But you know what I'm saying here? If there's a company or a superstar, you know, either singer or athlete or some other president that also has, you know, so many connections or somebody, right? That's not the typical reciprocal relation. I watch your picture, I click like, you watch my picture, you click like, and if you don't, I call you, hey, why do you like my picture? Right? So there's some relationships that are definitely biased one way. And that typically determines the flow. In the Ronaldo friendship with the followers, how the information flows from who to who? From Ronaldo to the followers, right? Because the followers have no information for Ronaldo. So this kind of thing affects how the information flows between the entities. We're going to need a few concepts and few tasks. So let's right here say concepts that are more like graph concepts. And we also gonna have a column here, tasks. Like, what is it that we want? For example, what we might want on a Facebook graph. We have this gigantic Facebook graph with everybody's friends with everybody. We don't have it, but Facebook does. Might want to detect community, right? So this is a subset. What's a community? If I say I want to determine a community of people on Facebook. Community, I'm using an informal notion here. What do I mean?
It's a group of relationships.
Group where
Everybody knows everybody.
it's everybody very, very well connected to everybody, right? So a subgroup of dense connections. That is out of, you know, say Boston people. So happen, that's a true story. My wife is from Colombia. She likes to dance. And she knows a lot of people in Boston area or even New England area who goes dancing. But this is a very well-defined community. If you pick 2 people or 3 people or 5 people that have dense connections, even the edges that are not there, they're likely to know each other. Right? So that's very typical for a community. If I have a bunch of things that are extremely well connected, even if an edge is not here, that's where the, you know, some systems, I think LinkedIn, every once in a while ask you, do you know this person? Because you're likely to know this person. How they do that? They notice there's a dense community of links and say, even though you're not declared friend or in a relationship with that person, maybe you know each other and you should put that link in. Right? Communication. So in here we might need a notion that's called clique in graphs. How many people know what the clique is in a graph? Yes.
N minus 1, like every node is connected to every other node.
It's a subset of the nodes where all connections are done. That's a theoretical notion. This is not a clique because it misses an edge. So we can't really use the concept as it is because that would require all the edges to be there. Right? What else we might want to do on Facebook? So we want to determine a bunch of friends, right? What else? Maybe this thing here, this edge here is predict new friendships, new relations. That is this edge here. If I notice a community, I could say, hey, not everybody's community connected to everybody, so I'm predicting that might be a link. What else? not necessarily just on Facebook, on any social media.
Major influencers?
Major influence. So, okay, I think everybody knows what that is in English, but what does it really mean for a graph? Ronaldo has a major influence, right? Because he has 20 million people follow him.
So it's
Okay, but what does that mean?
a lot of outgoing edges rather than incoming.
Okay, so outgoing edges. Or undirected edges, depending on how it is. So how does the influence work on this whole drama with the election in 2016? How did that happen? I mean, I'm not political at all. I'm neither Democrat nor Republican, so I'm not in here. Nor am I expecting FBI or anybody to do anything about it. But you've seen the news. How did that happen through Facebook?
Whatever the major influences post, I mean,
But
other people
who
are
is the
not-
major influence in politics?
leaders?
Right, so there's another notion that relates to major influence. If a news channel posts something like CNN, that's more likely to be propagated, right? So, but why is that? It's not just the links that CNN has or the Ronaldo has. There's another notion that's built in there that's much harder to credibility or trust. This has many names. I'm going to try to remember all of them. Trust, prestige, accuracy, independent in the sense of journalism, bias. This, I think today, without being an expert at social networks myself, I think is the core issue in social networks, the notion of trust. It's not how many links you have, but it's how much people trust what you're posting or what you're saying. It's also because I think by now, people have grown so used to Facebook and other, online mediums that a lot of stuff that seems like either boilerplate or advertising, it's instantly dismissed. I mean, how many times do you do that? When you see something like an ad or something that's saying sponsored or some email coming from where you bought the last pajama, right? You don't even read it, right? People have this instant mechanism to say, that's just saying their stuff is great, right? I'm not gonna read it. It's not because it's not great. It's because I'm not gonna read somebody who is gonna reply an email to like 100,000 of customers, same exact text, my stuff is great. So the notion of bias and trust, it's a big problem for news corporations because they need that. That's their business model, right? CNN, Fox News, Reuters, Washington Post, New York Times, all the other major newspapers, news organizations. Their whole business model is based on trust. That is not the case necessarily with somebody who manufactures computers, right? Most people buy devices for their reliability, but few people are wondering, I guess that's not true for cell phones, but for a car or for a laptop, you're not really worried that it's hacked in somehow and that whatever you do, people are spying on you. I mean, I know that has been exposing those security models as, NSA actually did that, right? They implemented something in the RSA protocol that they could break into encryption schemas, and that's called a backdoor. But most people, I think, they buy a computer or a car mostly based on reliability, how well it's going to function. They're not worried that somehow, I think that's only that's only true for cell phones. People are worried about, okay, how protected my cell phone is, who can get in, stuff like that. So the notion of trust is a big deal, and there's a lot of research of how to get trust from a social network. It turns out trust cannot be obtained from the shape of the network alone. We need to know a little bit more. We need to know exactly how data flow through the network. For example, things like liked. Things like how many of these picture or messages did you reply to from this other person? Okay? So it's not enough to know who's friends with who, because somebody might have easily 500 Facebook friends. We need to know what messages or posts were replied and in what way. Sometimes by analyzing the reply, we can estimate some sort of sentiment, whether I agree with what you're saying, or I disagree, or maybe I found your post maybe misleading or confusing or something like this. What else can we do here? So we have predict relations, major influences. So is this how the breakup into 2000 election worked? Was this the issue? Did somebody break into the CNN or some major news outlet and make them post something that was, I don't think it worked that way. So how did it?
There was a lot of fake news being circulated. It was
But the fake news didn't come from major, is that, I'm asking, did it come from major trust influences? No. So how did it propagate?
Could have bots, fake bots.
No, I put bots, but bots, why would a person listen to bots? Or like an unknown account?
Because you see that a post has many likes, but all of them are bots. So you trust that this might be right.
Maybe just mimic the sites and like name them something similar to the ones you trust, and people tend to believe them more.
So I call something instance CNN dot
Yeah, something like that. Yeah.
CNN X.
Yeah.
Or CNN Extra.
CNN.
And then whatever's posted, people see CNN, say that must be coming from CNN, or maybe it's a Facebook account on CNN, right? CNN 123, because my email is virgil123@yahoo.com. Maybe CNN account is also CNN 123, right? So that must be it, right? So I like that one. I didn't have that in mind.
I think when people see something on a platform, they assume it has credibility, even though you could take out an ad for $5 and post that without any kind of.
Okay, so that's good. Let's write this down, these ideas about trust. Might be more of a philosophical lecture then. So platform trust. That's, I think, what he's saying. It's not about CNN 123, it's about Facebook. Trust. The other one is that CNN 123 looks like CNN. And some users may not know that that's not CNN, it's something else. What else? Bots have a lot of likes, right? So let's write that. Somebody said that. Posts from bots that we don't know, there's no reason to trust those bots, have many, it's not just likes, it's likes or shares. I've been sharing that for so many times, like 85 million people saw it, must be good.
A lot of people will pay to post.
To post?
Yeah.
You mean like me personally posting, or?
Some people, I believe, are paid to post
Uh-huh.
political opinions.
So this is people are hired to act in certain ways. So whoever put like or shared is not actually expressing his opinion, is paid to do so.
But I think people already had made up their mind and this actually pushed them to the extremes. I don't think it kind of swayed.
Well, what's it again?
So I think people actually made up their mind. After seeing this, it actually pushed them to the extremes. So
But
they
if that's
see what they
true,
wanted to see.
if that's true, so all this happened, I think everybody agrees, Democrats, Republicans, everybody agrees that something happened on Facebook during the election. By now, I think, again, I'm not political, but I think everybody thinks something happened. But some people argue, hey, with all these issues, it's still your vote. You are responsible to go and vote for whoever, so it's like, too bad if you got influenced by the wrong CNN.
Well, it's kind of also like confirmation bias. So like
They wanted to
you
see.
think one way, you're like, okay, now I see it on Facebook, and someone confirms how I think, and now I agree with them, and then it becomes like a giant cycle.
Instead of, say, changing my mind. That's
It just
not
is,
the-
yeah, just making me.
No, they actually see what they want to see.
Right, yeah,
Even if they're not.
I'd say the biggest problem with all this, no matter what happened, I'm not claiming I know what happened. Something happened. It's actually people not being educated. Not just into Facebook, into believing this or that, or not being able to distinguish the CNN versus CNN 1, 2, 3, but also in not understanding what they're voting for. When you say, I'm voting for, say, a Republican president or a Democratic president or for this guy or for whatever change in the Constitution, whatever it is, how does that affect me? Most people don't understand how policy and government works. So they vote by things like sexual scandals, emails, all kinds of stuff. Even if that would be true, maybe it is true, I don't know, it wouldn't affect much how the government or the president changes your particular life. You know, things used to be much simpler 100 or 200 years ago. It was much more obvious if I vote for this person, what are you going to do for me? Now, a lot of these scandals, I think, or a lot of the influence is not just this fake news. A lot of people are concentrating on the fact that it's fake, that's not argued, that's not justified, it's not verified. Even if it would be, would that change anything? Would it make president a better or worse person? I don't know. I remember something with some emails from Hillary Clinton.
Yeah.
Even if she sent those emails from a basement like they say they did, would that make her a worse person to be president? Or even if Donald Trump did what he did in the past with other people, would that really make him a bad president? You know, I think people need some education into not just the how to learn how to navigate the social website or their email or whatever it is, but also how much impact that has to do. And I think that's more general. I think it's not just on Facebook. I think when people buy a car, the advertisements for cars are designed to woo whoever's a customer into things that they don't really need. So instead of paying attention to, okay, is this properties of the car really matters to me, independent of whether the properties that actually work like the ad says they do, I think most people are going for something that looks extremely good on paper or has advertisement value, but doesn't do much. And I want to point out one more thing here. I think there is an American bias into this. In my experience in Europe, especially Western Europe and Asia, people are falling less for this kind of sparkling that has no meaningful value that in Western societies. And I would say South America too. Okay, so trust, we got that. We have to add some concepts here, because I mean, how do we do all that? We need some things like degrees. We know what a degree is, right? From the vertex. Which actually, there's 2 degrees. In some graphs I may have in degree, out degree. Let's see. We of course need the concept of a path. How can I get from somewhere to somewhere, right? And very quickly we get from paths to shortest path. I'm going to call those SP from now on. In graphs, simple stuff is simple, and hard stuff is very hard. In graphs, things tend to complicate very, very fast. So as soon as I move away from the simple stuff, you guys probably know shortest paths already. That's not a trivial thing to do, shortest paths. What else I may want to do here? There is other concepts. Influence, I think in the way we've written here, it's outgoing influence. Like if I post something, how many people follow me or get that information? But there is the incoming influence. This is a big deal, mostly not on the social graphs, but on the web graph. This has to do with reachability. By navigation. There's a very famous metric for this, right? If I look at web pages and somebody say navigates the internet, how likely is it to find my page or to visit my page? We all know that. This something very famous. Page rank. It's more famous than useful. Turns out it's not that big of a deal, but nevertheless very famous. So this notion here has to do with if I do something on the internet, how much do I influence others? This has more to do with, okay, how many things have a contribution to my page rank. Page rank depends a lot of the incoming edges, right? And this influence depends more on outgoing edges. But those are different graphs. The web graph is different than the Facebook graph, very different. I'm gonna list some other notion because they might be conflating with those, but they are very popular in data science. The hub notion. How good something is as a hub. Relates also to navigation, but it could be applied to Facebook. What makes something a good hub? When do we say something like a node, either in the web graph or in the social graph, it's a good hub or popular hub or big hub?
A lot of incoming, a lot of outgoing.
Essentially, it's basically centrally located where it aggregates a bunch of incoming traffic and then groups them and routes it into other areas.
Right. So I think a hub means easy, from it is easy to get to good information. Let's say in the web graph, what would be a good hub? Web graph. Something that when people land there, they kind of trust that, and from there they can navigate to their answers, whatever they're looking for. Wikipedia. How about between Wikipedia and CNN? Which one do you think people trust more? Right? That's a recent thing, by the way. Wikipedia beat CNN. CNN used to be more trusted than Wikipedia, but for some reason they moved so much into the left side of politics. CNN. Maybe that's a good thing. Again, I'm not in politics. I don't know if that's good. Maybe they have more viewers this way. That people tend to trust more Wikipedia now than CNN or Fox News or other news channels. And the corresponding notion, authority, is the same as trust. Items with high trust. There's other notions like connectivity.
let's add them here.
Of course, this relates to income and outgoing. Going. And there's a notion that centrality, but this is special for some graphs. What does it mean to be central? And one notion that I think this is the first thing that you probably don't know yet, is, I believe it's called betweenness. Yeah, betweenness. Am I spelling this correctly? So I would say, I would expect most people have heard of the other stuff, but not necessarily this one. What is betweenness? In informal, common English, we're going to call this, that has to do something with a bottleneck. I'm not saying it's equal to the bottleneck. I'm saying betweenness has to do the notion of a bottleneck. And we're going to need more, I think, more tools on graphs. Degree, connectivity, shortest paths. So now, there are some other notes before I move on. Let's see, there's some other tasks here that I'm trying to get to. There's some classification tasks. That is, if I know, like in supervised classification, if I already know I have the Facebook graph and I know some people who they vote with already for some reason, can I predict other people who they're going to vote with based on the Facebook graph? So assuming it's supervised. And I think there's an item with analysis here. This is, I think, concerning more like patterns. If somebody is reporting, say, a storm or an earthquake or some problem, who's likely to be affected by that sort of thing? Sometimes Facebook may not be the right tool to do that. Sometimes, if people have cell phones, there's emergency services that work. Sometimes emergency services go down and people find a way to post things on Facebook rather than getting cell signal. But there's also a lot of market value in this. So this has a lot to do with this notion of influence and advertisement. By the way, advertisement is a much bigger deal than people realize and than computer scientists realize on social networks. We even us who understand very well how this stuff works, perhaps some of you had internships or interviews at Facebook and Twitter and other places. I think most people, that advertisement is added on to the purpose or the value of the network. So we have Facebook, so the purpose is to share things, to see pictures, to have connectivity, to put events and connect to our friends. And advertisement comes on top of that as that's how Facebook makes money. In reality, it's a little bit of the opposite. Advertisement is the foundation of how the networks work. And a lot of things that happen or don't happen in a network is based on the ability to monetize it, to make money out of it. Google works the same way, by the way. The biggest research at Google is into how to sell more ads, okay? That's what people primarily work on, how to sell more stuff. So why is that? Why can't we have a social network without advertising? Can we pay for it? I think YouTube does that now, right? You can pay for it, get rid of the ads. Why people don't want to do that? Is it really worth this flux of ads that we have and the possible bias? The fact that somebody intervened in an election was definitely due to the fact that Facebook was trying to make money. If Facebook wouldn't be in the business of selling people's data, that wouldn't be a problem, but then Facebook would need a way to make money. So why can't we have a social network where people can pay? Say, you don't get ads, we don't sell your data, but you have to pay $5 a month. Would you pay?
No.
Oh, I mean, if you use Facebook, would you pay? How many people subscribe to YouTube? They have the YouTube paying thing? Huh? How much is it?
It's like 10.
No, it's not 20.
It's like 10.
$10 a month, right? And you get to watch videos without ads, right? And music, I guess. So anybody's doing that. Why not?
We're used to it.
Huh?
We're used to it being free. We don't want to pay for something that we're used to having it free.
But what is worth to pay $10 or maybe $7 to, like you pay for Netflix, I'm assuming some people have Netflix, right? You don't hack it, right, with your friends. At least somebody must pay, right? So why is it that on Netflix we pay, and I think people have maybe Spotify accounts, what else? I think people pay a lot. Amazon Prime accounts, people pay that a lot, right? But not Facebook.
Depends on how much you value your data on the Facebook.
You don't value enough to pay $5 a
No, I
month?
don't put enough information there.
Okay, you don't use Facebook, but
I use, but yeah, not a big deal.
but let me ask this question backwards. If you'd be willing to pay, if you're one person, Facebook, I think, can easily sell you that service for $5. Okay, you don't want me to sell your data, right? You want to be, okay, protected, $5. What if everybody chooses that service? Can Facebook do it? Can Facebook say $5? We don't sell your data. Would that work for them?
They would lose their advertising.
Would that work for them?
Because wouldn't they lose their advertising base? Kind of?
They lose the advertisement, but they get the memberships, right? They get the fees membership. So how many people are on Facebook? 1 billion? Imagine make $5 a month, 5 billion a month, right? That's 60 billion a year. Would that be enough money for Facebook? I think so. No?
Hopefully.
Yeah, they're
They wouldn't need to
only
sell
for
anything in ads.
It's international, not everyone in other countries might not be willing to pay for as much as $5.
Not everyone will pay, so the problem with some people paying and some people not paying, it's a well-known broken economic model. I think maybe some of you, because we're computer scientists, we didn't go to the economic school. That's a well-known problem for economy. Here's why, the basic simple version. Who pays? If half of the people pay and half don't pay, who are the ones that are paying in terms of income?
high income.
Definitely the high income, right? That is the same with TV shows on iTunes. I can pay on iTunes for the TV show, $2 an episode, or watch it on TV with ads, record the DVR, whatever, right? For free, because I already have TV service. Who do you think buys the TV shows for iTunes? The highest income class, right? But from the advertisement perspective, I still advertise to the other half of my customer base, right? So advertisement is trying to sell things anything. It doesn't matter what, right? So the problem is if the high income half pays for not seeing ads and the low income doesn't pay, so they see the ads, from the advertisement perspective, I'm showing my ads to people that don't have any money to buy them. That's a big economic problem. So this model cannot possibly work in a wide open economy where everything is connected if the people who have the money, they're not exposed to ads to buy whatever there is to buy. And some of these ads are legitimate, right? I mean, every once in a while people need to buy something, and ads are useful because they point them out to what they might want to buy. I don't say all ads are bad either. So the problems with advertisements are big economic issues. Let's put it here. I want to say complicated with scale. This, of course, wouldn't be a problem if Facebook would be a small company with 100,000 users. But when those companies get so big, there is a guy at New York University, economics professor, whose entire career is based on how economy is changing due to Facebook and Google and Amazon online companies. Because they are so big, they control a vast amount of the economy. And by issues, small issues like changing very, very small numbers for 10% to 11% affects not just that company, affects an entire industry out of it. It appears now that Amazon, for example, could easily take over shipping industries. And that would be a huge economic problem. Okay, so now back to computer science. How do we do some of this stuff? So we'll talk today, tomorrow, and maybe let's see what we're gonna do on the last day about how would you do this. Say that's task number one, community detection. If you have the Facebook graph, can you determine what is a community of people? We need some ideas for how we might be able to do that, right? It's not as easy as looking for clicks. By the way, clicks to look for, it's an expensive thing in a theoretical sense. If I give you a large graph and say, find me all the clicks of size, I don't know, 100 or less, all the nodes that are all connected, that's a hard theoretical problem, and very practical for this because communities occasionally would miss an edge, and they will not appear as a theoretical click, but they will be a community in the sense that we want. So how can we do this? What would be a strategy? What would be the community in this graph right here? If this is a Facebook graph, which one do you think are communities? They kind of look like this and like this, right? Just eyeballing it. How can I determine that? Yes, easy. Strongly connected components might have the same problem like clicks. Strongly connected components only refer to directed graphs, right? Otherwise, they're just connected components. And in a strongly connected component, I require paths from everywhere to everywhere in that component, but they may not necessarily be true in a community. Not everyone to everyone in a community has a path. And like I said earlier, some of these edges are actually undirected, like Facebook friendship. So it's really connectivity alone, just connected, is too loose of a notion. Facebook is probably a connected graph. There is a way to hop around from friend to friend to friend to get mostly from anywhere to anywhere. You guys agree? That most of the people are connected in the sense that there is a way to hook to various people and entities and friends, and now people are friends with Cristiano Ronaldo, and they're friends with you know, I don't know, some superstore that sells a lot of stuff. It makes it easier to be connected theoretically, where it's not really part of my community. If two people are friends with Ronaldo, they're not really from the same community necessarily, right? So connectivity is too weak of a notion for community. what else can I do? So I'm looking for some ideas. What would be the principle that I need to apply here to get those pieces out? I could go by the clicks and evaluate for a click. Click I don't define as a 0-1 notion. It's either black or white. Instead, how can I measure how click-esque something is? I get a bunch of nodes and I say, okay, it's not a click because it misses at least one edge. How close is to a click? How do I measure that? What makes this a click again? If it's a click? Has all the edges. How many edges are there? In a click, you need to have all k choose 2 edges, right? There's k vertices. So how can I say something is close to a click?
When they are close to this number.
Huh?
Close to this.
I look at the click subset and I count how many edges are there, and I say the click as value is the actual number of edges divided by how many edges a click is supposed to have. If this number is 1 or close to 1, it means it must be very dense. It has almost all the edges. If this number is close to 0 or to linear, that means it's not that dense. So click can be defined a little bit soft, like not exactly black or white. But even then, clicks are hard to work with. If I really look for a fast algorithm, what would be my best bet in here? Detect the bridge. That's the one. I mean, that's not mathematical yet. Can I detect this bridge? Can I have 2 bridges there? It's possible, right? I mean, in a Facebook graph, when everything is very dense in the click, in people's communities, it's not necessarily that from there's only one bridge. There may be 2 bridges. So I can't really detect just one bridge, but I really need to put my hands on these edges that are connecting components that are not well connected. Bridges, it means, is like the edges that are unlikely between communities. So bridges. I'm using his name. This is not an actual name. Are the edges that are rare between communities. Like this edge here, AB. So if somebody tells me these are the bridges, would that be a done deal? Can I determine the communities now? How?
Which are the bridges, so you know what are the connecting components?
Well, how do I do it? How do I determine the components? If somebody tells me the following edges are those rare bridges between your communities. It's simple, I know, but how do we do it? We what? Remove the bridges and see who's still connected. Right. Okay, good. So that's how community detection works. We want community detection, we need to put our hands on these bridges. Bridges might be edges or nodes. I don't know, right? Is it possible to have a large community here? Large community. This is a community. 1. It's another community 2. And they all seem connected to one node. And I don't know if those qualify as bridges because there's quite a few of them. But this definitely qualifies as a pass-through node, bridge node, as in from here to here, you got to pass through there. Right? So the notion of bridge, in that sense, that is between the communities, it's either some edge that's important, it's the edge that I need to take out or that connects to communities, or some vertex that makes those two things connected. Okay? So what do you think? How do I put my hands on this? I need to run some graph algorithms, right, to determine what makes a good bridge or a likely bridge. Now, I'm not going to be exact all the time. In huge graphs, in small graphs, it's a theoretical problem, right? In big graphs, you're going to be right most of the time. Sometimes we're going to be a little bit off. But it's still okay to keep running our algorithms. So this would make a good algorithms final question, right? Notion of a bridge, the one that kind of connects communities. How do you find it? So you are welcome to run all kinds of graph algorithms now to determine the edges that appear between components that are very well connected. We can quantify that mathematically, what does it mean to be a bridge? But intuitively, how we find it? What the bridge needs to have to be a bridge? Why is this one a bridge, this rare edge between communities, and this one or this one is not? What makes, in English, please, the difference? What?
Do you have common neighbors?
What?
The edge which joins two nodes should have common neighbors.
The edge who joins two?
Nodes,
Yeah.
and both nodes don't have common neighbors.
Those A and B don't have common neighbors other than them, other than each other.
Right.
Okay.
So there's no like cyclic path back. So once if you pass the bridge, you can't trace back to the.
But why? I mean, as I said, the bridge might be another bridge. Theoretically speaking, if this is a large community and a large community, this is all the people who are computer scientists, say professors in New England. They likely know each other, right? Because we know who's computer scientists. And this is all the people that are, I don't know, dancing waltz. Also likely to know each other. Now, there might be more than one person who's dancing waltz and is a computer scientist, right? It doesn't mean there's only one bridge. But these are rare, right? How many people in computer science dance waltz? This is probably listed by like one hand. So I want to write that down. How to characterize a bridge. I'm going to have to erase something. So bridge, again, rare connection between dense components. If this is a bridge, A to B, one characterization was A, B have different neighbor sets. I didn't say that. He said that. He said that if you really want a bridge, it means if you an edge, you look at A and B can have a lot of common neighbors. Otherwise, if A and B have a lot of common neighbors, right? Can this still be a bridge? Can this still be a rare thing if A and B have a lot of common friends? If me and him have a lot of common friends, 1,000 friends in common, can we really say the edge between me and him is a bridge edge? No. That seems like a good characterization. In English, I'm not saying it's good as far as finding it. I mean, there's one thing to say, that's what I want, and another thing to say, here's a graph, find me A and B. No, right?
Remove,
I agree that makes sense, but how do you find A and B? Where's the bridge?
remove the least amount of edges that makes the traversal impossible.
What? Say again?
The least number of edges when you remove
From
it
the graph or from some path?
from graph.
Remove the least edges that makes it untraversable from one end to the other?
For the whole graph, untraversable.
So it disconnects the graph.
Yeah.
Okay. So these are the characterization that A, B. So we want the sets A, B edges as a set of edges that's minimal and disconnects the graph. Makes sense? I agree, right? Like if I want the fewest number of edges that disconnects the graph, but there's some problem here. One is the same problem as before. Easy to say, hard to do. Find that minimum set of edges. Secondly, what does disconnect means? Is it enough to just disconnect one node? Right. Maybe I have another node here, like that. To disconnect it in a theoretical sense, I can just erase this edge, and now it's disconnected, but I disconnected a little piece out of it. When I say determine communities, I mean all communities or large communities or something like this. You have to define what disconnected means. It's not enough to disconnect a little piece out of the graph and still have the whole Facebook graph connected. Like if I have only one friend on Facebook, disconnect that edge, I'm disconnected now, but the rest of Facebook is still organized into communities that I didn't find. So this is a vague word. What does it mean? It's not enough to disconnect just a little bit. Not to mention that I think it's hard to find that minimum set of edges that does that. Pretty sure that's an NP complete problem. What else? How about this stuff that we say maybe it's new? Right? And maybe the name doesn't say much, but how about the name bottleneck? What has to happen to those edges that are those bridge, rare edges? Very special to us. This and maybe this. I have another community in here. There's two edges that I'm looking for.
There's only one way in and out.
To pass from, it's like the disconnecting idea, but more formal. To pass through the graph from one component to each other, you need to use those edges. The difference between this edge and this edge is that there's some paths in the graph that must pass through this edge. Right? If I want to go from here to here, I have to go through this edge. But this edge is not mandatory in any path. Anywhere to anywhere I want to go, I can avoid this edge if I want to. Right? So how do I say that more formally? I want the edges that are somehow part of the bottleneck. Like if you want to go from there to there, you have to use them. Versus the edges that are not really part of the bottleneck, you can avoid them if you want to. I need to quantify it not black or white. I need to quantify it numerically. Like this property of a bottleneck property. It's not enough to say 0, 1. This is a bottleneck edge in the sense of 0, 1, right? Because you have to use it if you pass from there to there. But like I said, there might be another one. And then I need a more quantity like, if you pass from there to there, how likely are you to use that edge, or how much pressure is for you to use the edge versus not. So some numbers that are high will indicate that that edge is part of the bottleneck or likely part of the bottleneck. Some numbers low would be like, this is probably not part of the bottleneck. Yes?
Especially part of the minimum spanning tree, part of every minimum
That's
spanning tree.
closer, but it's not the minimum spanning tree. Very close. You are in my algorithm class? No. So we had a discussion there that there's one thing, the minimum spanning tree, which is the total minimum weight to connect everybody. And there's the other notion, which is shortest paths from A to B, which if you put them all together, all the shortest paths from everywhere to everywhere, you don't get a minimum spanning tree. But there are similar notions. So what we need is the second one that says if you look at all shortest paths, or sometimes people use all paths. If I look at all paths from here to here, what should I ask? How many of those paths pass through that edge?
So you need to detect for all the edges, right?
Right, I have to do this for every edge. But I don't know what paths to measure from where to where. How do I do this? Like, I have a notion now. I know this is a bottleneck. If a lot of the paths from somewhere to somewhere pass through it, but since I don't have the components detected yet, how do I say paths from here to here?
Take the path from one node to every other node.
Okay. So if I take all paths from two nodes, UV, right? I ask what fraction of them passes to edge, what do you say here, AB. So I could write that as a fraction. I could say, here's the fraction for edge AB characterized by UV, because this is the paths from U to V on that edge. This is the number of paths that contain, number of paths between U and V that contain edge AB versus all paths from U to V. So this is how many contains the edge versus all the paths. If all paths contain that edge, this fraction will be 1. But then I don't know what UV to use for. The edge is fixed. I'm looking at one edge right now, edge AB. But who should be the U and V?
You do it for every pair.
I have to do it for every path UV, right? So do this for every UV.
So you need to do something like Dijkstra to get,
Hmm?
you need to do something like Dijkstra to get from all nodes to all nodes and then.
Right, so there's the other thing, which is, do I want to consider simple paths or shortest paths? When I do this, I'm looking at the bottleneck edge. Should I consider all paths or shortest paths? That's a subtle argument. You can argue that all paths have the bottleneck condition. Certainly in one way it happens. If this is a bottleneck edge, it will be a bottleneck for paths and for the shortest paths. But to detect it, it's easier just with the shortest paths. Because the shortest paths are the ones that avoid cycles, are the ones that can be detected by BFS easily, so on and so forth. So I need, first of all UVs, and then I'm going to use the shortest paths instead of general. But then, even though I define, I have a little bit of a framework, what do I want? I want to figure out those edges, the bottleneck or the bridge edges or the between edges. Okay, that's what I want. I know how to do it. A between edge is gonna be an edge that's on a lot of the paths. So I have to measure paths or shortest paths. I'm gonna need a graph algorithm that deals with shortest paths. If I have just connectivity like in here, the edges don't have weights. Every edge is a 1, right? How do I find shortest paths from U to V in such a graph? What do I run to get the shortest path?
BFS.
Hmm?
BFS.
What's the first letter?
B, that first edge.
BFS. If all edges are unit 1, either white or black, I run BFS starting from a node, and I get the shortest paths to everywhere. Are we all on that? I know people in the algorithms class did that, but even if we did algorithms 4 years ago, we remember BFS, right? What if the edges have weights?
Dijkstra.
I run Dijkstra algorithm. And another thing that we're gonna need for shortest paths, that will be on Wednesday, is this algorithm, BFS or Dijkstra, they don't just give you the shortest path from U to V. They give you what?
All pairs, shortest path.
You can run it for all pairs to get all pairs from everywhere to everywhere, but they also give me a tree that is the shortest path tree. So you should remember from the undergraduate algorithms class that either BFS or Dijkstra creates a shortest path tree. Now I want to specify something that perhaps really needs a recap in the shortest paths algorithm, not for people in the algorithms class, just for everybody else. What happens in BFS or Dijkstra when I already have my shortest path tree? We all know that this advances, it only uses some edges of the graph, right, to advance to the next. BFS is the next wave, Dijkstra is the next minimum, right? Definitely creates a tree. And what happens when I have, here's a new node. This is my existing tree. So this is the shortest path tree, either BFS or Dijkstra. Again, that depends on whether the edge have weights or not. What happens if I have two edges in here? In the case of BFS, they're just edges. In the case of Dijkstra, say they have the same minimum, 1 and 1. What Dijkstra is going to do, or BFS? This is my existing tree, and I'm expanding the tree to go to the next node. What am I doing now? I'm recapping 3 algorithms from many years ago, right? What do all algorithms do when there is multiple ways to expand? I could either use this edge to include this node, or use this edge. In BFS, simply means there is an edge. So to get to this next node, I can use either that or that. In Dijkstra, they have to have the same minimum for Dijkstra to include that node next. But what does algorithms do in this case? Which edge gets selected? Or how did they select both? Or how did they work?
They select one.
How? Based on their queue implementation, Dijkstra and Prim and BFS use a queue. Depending how that queue is implemented, it may be this edge or that edge, right? So this is important in here. If multiple options for expanding tree, choose one. The stuff that we're going to need is to say, no, we want both of them. So I'm not saying go home and modify Dijkstra. I'm saying for what we need, we might need to have both those edges. In other words, I'm not going to get the tree. Is this a tree now? Not a tree anymore. If I do both edges, meaning I have 2 possibilities to arrive at that minimum next tree, either in BFS or Dijkstra. And because there are 2 possibilities, Dijkstra would choose one of them. But I want to keep track on both. So I may have something like this, and now this is a third possibility, right? And this is another thing that's, what is this now? It's not a tree anymore. It's a what? It's a DAG. So from a tree, I get to a DAG. And these edges that Dijkstra and BFS calls the advancing tree edges, community detection people call it tight edges. I would say a really unfortunate name, but that's what it is. If you read the book, it says tight edges. Tight edges are the ones that could be used. There's some shortest path that passes through them. And because both are tight, right? Both can be used for shortest path. I can't just select one of them. So tight edges really mean the edges that belong to some shortest path. Of course, there'll be edges that are eliminated, just like in BFS and Dijkstra, edges that are not on the shortest path. I don't care about those. And so I have to figure out how to use these to get this. Now, what happens if I can't get, you know, if somebody would tell me those are your bridge edges, what did we say? Just remove them and you got your communities, right? What if somebody doesn't tell me which ones are the bridge edges, but gives me the bottleneck scores? So on every edge now, I have a bottleneck or bridge score. The highest the score, the more of a bridge that is. The lowest the score means it's not really a bridge, it's part of a cliff maybe. I can't just remove all of them, because then I have no edges left. I can pick a threshold and say, pick a threshold, remove all the edges above that threshold. That may not do what I want though. How should I proceed if I really have these bottleneck scores that are not numbers between 0 and 1 now? They're not black and white. Sort them, fine. Get the highest edge that has the highest bottleneck score. Do what? Remove it. And then can I keep removing the next one? So I sort the edges by this bottleneck scores, right? We didn't say quite yet how to compute the bottleneck score, but we have a plan. It has to do with how many shortest paths pass through that edge. So we can compute, say, those numbers in advance. Pick the edge that has the highest bottleneck score. Remove it. Analyze the graph again. Can I just go and next remove the next bottleneck score? Or do I have to update the bottleneck score? That's my question. If I remove an edge, the highest bottleneck score, do I have to update the rest of the edges bottleneck scores, or I can just use the ones I pre-computed?
You can still use it because they will be proportional.
The truth is they need to be updated if I use all UVs, but there's a way to do it smart. If I remove this edge, the bottleneck score of this edge now will not have any path from here to here because this is disconnected, there's no path. But all the paths that contributed to that edge before, from here to here, they can still there, right? So I have to find a way to kind of recompute the bottleneck scores, but not from scratch. Right? I would need to keep track of something so that then once I remove this edge, I can compute the bottleneck scores to next. And then I can repeat that process. If my graph is not disconnected enough, if I want to keep disconnecting it, remove the highest bottleneck score, update, keep going. There's a name for this. We're done. The name is Gervan-Newman algorithm. The algorithm is very easy, apart from this bottleneck updating scores. So that's what we're going to have to do next time, and there'll be a question in your homework about it. I can't make office hours today. I'll be there Tuesday and Wednesday, and if necessary Friday, but I can't come today. So for that reason, I asked him to take the camera.